Hi guys, in this presentation, we will explore about the properties of pure substances. But before that, let us browse what the topics covered in this chapter are. There are 6 major topics to be discussed as in the following list. Do you know what pure substances are? A pure substance has a fixed chemical composition. Some examples of pure substances are water, nitrogen, helium, and carbon dioxide. A pure substance does not have to be a single chemical element or compound. A mixture of various chemical elements also qualifies as a pure substance as long as the mixture is homogeneous. Air, for example, is a mixture of several gases, but it is often considered to be a pure substance because it has a uniform chemical composition. However, a mixture of oil and water is not a pure substance, since oil is not soluble in water. It will collect on top of the water, forming two chemically dissimilar regions. A mixture of two or more phases of a pure substance is still a pure substance as long as all phases' chemical composition is the same. For example, a mixture of vapor and liquid water is a pure substance because both phases have the same chemical composition. A phase is identified as having a different molecular arrangement homogeneous throughout and separated from the others by easily identifiable boundary surfaces. This can be shown in the following figure. The variation of a pure substance molecular arrangements for different phases can be clearly seen based on this figure. The gas to liquid to solid phases corresponds to the substance properties such as temperature and pressure. For example, at room temperature and pressure, copper is a solid. Mercury is a liquid. And nitrogen is a gas. Under different conditions, each may appear in a different phase. There are 3 principal phases which are solid, liquid and gas. A substance may have several phases within a principal phase, each with a different molecular structure. Carbon, for example, may exist as graphite or diamond in the solid phase. Now, let us find out the difference between them. How solid phase of a pure substance behaves. The solid molecules are arranged in a lattice repeated throughout. Because of the small distances between molecules in a solid, the attractive forces of molecules on each other are enormous and hold the molecules at fixed positions. The velocity of the molecules during these oscillations depends on the temperature. At sufficiently high temperatures, the velocity of the molecules may reach a point where the intermolecular forces are partially overcome, and groups of molecules break away. This is the beginning of the melting process. The liquid phase molecular spacing is not much different from that of the solid phase, except the molecules are not at fixed positions relative to each other, and they can rotate and translate freely. The intermolecular forces are weaker than solids, but stronger than gases. The distances between molecules are a slight increase as solid turns liquid. In the gas phase, the molecules are far apart and a molecular order is non-existent. Gas molecules move about at random, continually colliding with each other and the container's walls. Molecules in the gas phase are at a considerably higher energy level than in the liquid or solid phases.